Hello everyone. Hello everyone, and welcome to another video of building our own operating system. Last time we were working on numeric expressions and ran into a little bit of problems, so we weren't able to finish it. So this time we're going to come back to that, finish that off, and then see how far we can get in this episode for today. So I'm going to just go ahead and set up our environment variables, and we'll get back into the code. So where we were last time was we were processing, doing additions and subtractions for the times keyword, and we were doing multiplication and division for the DB instruction. And we were trying to marry those two things together and process them so that we could evaluate an expression like this, where we have both addition and multiplication in the same calculation. And I figured out, I kind of tricked myself up. So let's just go ahead and re-enable this code and we can go back. So if you look here, what we're doing is we're first, we say, oh, okay, it's a times, so I expect then I'm going to get the next token and I'm going to handle it. And we kind of expect it to be a numeric, either a decimal or a hexadecimal. And then we're going to continue processing that so long as it matches, so long as the next token is a plus sign or a minus. And that kind of tripped me up when we were working on the expressions, and that's where we kind of ran into problems. So what we really want to do is we really want to take all of this code here and we want to extract it out. And what we're expecting to do is, this is the times, so it's going to be, we want to pass in the token and let that handle looping over however many decimals and hexadecimals there are and what the extra symbols are. Okay, so let me double check what the parameter is here. So for expressions, it's additions. So what we want to do here is when somebody calls in to process a numeric expression, we're going to basically expect that that first token is a decimal or a hexadecimal. So we want to handle that case, and then we're going to continually loop after that. So it's basically this very similar to this code here, but we're going to use a do-while loop, which isn't commonly used, but it's going to do exactly what we need in this situation. So we're really going to, wow, I'm messing up on that one today. We're going to do some conditioning here. So what we're going to do is we're going to say I think another part of it was the logic to get this right is completely reversed from what we had written in the first place. And so I think that was also playing into why I was struggling with what we needed to do. So tokens now needs the tokens now a pointer, so we have to do that. So we're going to say if it is a plus, we want to do something. Otherwise, if it's a minus, we'll do another thing. And then if it's not either of those, we're going to just hand it off to numeric term and let it handle what the value should be. There's a little bit of duplication here of the logic, which isn't great, but let's not stress about that right now. Let's just get it working. We can deal with trying to simplify it, make sure we don't have any kind of duplication. We can do that later. All right, so if it's, where is my, so we don't want that, we want to change it. Actually, this should be, what's the text? So I think that's the code that we want. Okay, so let's go over what this is doing. So it's saying anytime somebody believes they have a numeric expression, we're going to first see, okay, is it a plus or a minus? And then we'll go into, we'll consume that token. So then we should expect either a decimal or a hexadecimal. And we're going to then hand that off to the numeric term, which will handle the things that we need out of that. Otherwise, it's something that numeric term needs to handle. So numeric term is going to look very similar to this, except it's going to deal with the asterisks and the slashes. Okay, and then for right now we have our factor just basically handing back the token value. So that should be the actual value of the decimal or the hexadecimal. Okay, so let's update where we're calling. And looks like we did it for times, but we need to do the same thing for dB. that's right. Except this shouldn't be, it should be value. Where are we? What is this? Missing semicolon before bracket, illegal. And then this has to be downcasted, of course. Okay, so let's take a look at our input file. So we're doing just one. So let's go ahead and just say here we want to do something like whatever we had in that example, 3 plus 4 times 2. It's right here. There we go. Of course, that didn't come out for some reason because we didn't run it. So we get 3, is that right? 4, that's not right at all. 4 times 2 is 8, plus 3 would be 11. So let's step through this because it's a little confusing. Let's just make sure we had it all right. All right, let's get rid of this. Let's go ahead and run. Okay, let's take a look at the token here. So we are, in fact, processing our 3 plus 4 times 2. So it's not a plus, it's not a hyphen minus. So we're going to take a look. We're going to let numeric term process it. And that's going to come back, and it's still not an asterisk and not a slash. So numeric factor is going to say, what is it? That's going to come back as 3. Okay, then it's going to say, you know what, I think it's not going to then do anything. I think what, okay, I believe in factor we have to advance the token as well once we pull out the value. Let's just try that and see if it fixes it, and if not, then we'll step through. Okay, so there we get B, which B is of 11 in hexadecimal. So I'll go ahead and step through that anyways, because it is kind of tricky. So you can see here what our what we're trying to process: 3 plus 4 times 2. So we're going to step in here, and it's not a plus, it's not a minus, it's not an asterisk or a slash, so it's a 3. We then need to advance the token, or we need to move to the next token. So that's what this is going to do. I'm not going to step through that. So now we're at the plus. So the numeric term comes back and says, okay, if it's an asterisk or a slash, I want to continue doing stuff. It's not though, so it's going to return that back to numeric expression. And then numeric expression is going to say, if it's a plus or a minus, I want to continue processing. It is, so it's going to consume the plus, and then it's going to say, okay, the next value should be a decimal or a hexadecimal. So it's going to, well, it actually doesn't know that. It's just following the what is it called? It's order of operations. So we have to let numeric term then handle it, and it's going to say it's not a multiply or divide. So get me the value from factor, and then it's going to advance. So right now results 4, okay, but then numeric term says, oh, it's an asterisk. I get to handle that. I'm going to consume the asterisk, and I'm going to go figure out what this next factor piece is, which is going to be 2. And so then it's going to take 4, multiply it by the 2 that we were just getting back from factor. That increases the result to 8. And then numeric expression is going to do the same thing. Remember, it had the 3, and it's figured out. Now we've processed the 4 times 2, and so it's going to add 8 to 3, and now it results 11. And so then that's what the value is. It's 11. Then we're going to just output that to the file. So that's how that works. Now so we would be able to do this type of a expression all we want, but sometimes there's cases where you want to do something like add 2 to 3, I'm sorry, add 1 to 2, like this, but you want to take that into account before you multiply it by the 4. And currently we're not supporting parentheses like this. So let's go ahead and add that, and that's going to go in the factor portion. If you notice right now, the factor is just taking the raw value. This is where we can handle the parentheses and get the correct order of operations. So let's go ahead and do that. So if we go back up, oops, let me double check the order I want on that. All right, so we've added the tokens. We need to detect them. So let's go ahead and add it here. Oops. Okay, so now we can detect that token, but now we're not handling it. So if we go to the factor, trying to remember if we... I think we need to loop here as well. Do a do loop. All right, so if the token type is the difference here is that instead of just taking the value, we want to evaluate what could be inside the parentheses is in itself an entirely secondary expression. So we want to be able to call numeric expression on this. Now, this won't compile because we haven't defined numeric expression. So we have to oh, I can't remember the name, what the term is for this, but we have to basically pre-declare it. Right, and then we have to say, basically, we have to basically say we want to continue the loop while we have left parentheses. So that'll allow people, or allow the parsing of something like this. So when we first detect this first left parentheses, we're just going to continue saying, oh, that's an expression, go figure out what that is. And then it's going to just keep doing that, I think. So let's see, what's this going to be? 4 times, let's see, 3 is 12 plus 3 is 15. So it's going to be, should turn out to be E. And it comes back as 3. So that's telling me that we didn't process the expressions properly. So let's just double check that. Whoops. Okay. That was really bad. Okay, I'm missing getting into where I want to go. Let's see, so this should be 3 that we're trying to figure out. So we don't really need to do that. That comes out. It's a plus. Let's look at the next one and go figure out what it should be. That's going to be the 4. This is going to be the multiply, and now we're going to hit the parens. Okay, so it should have detected the current token as a left paren, but it's not. So let's double check the, well, yes, if you have the right character for the detection, it will work correctly. Okay, so we get a hang. All right, so this should say it's a left paren. Oh, okay. I forgot to, we need to consume the token, which is the left paren, move to the next, which will then allow us to do the inner expression, and then this consumes the right paren, and this one consumes the value. So we get F, and I thought we would have had 12, 15. Well, that's right, F is 15. I don't know why I thought E was 15. F is 15, so that's right. So because when we had that, it came back as an E or a B. B. Yeah, that's right. It was a B. Okay, so that fixes that, and we can kind of do now crazy arbitrary values in here. So we could say all of this minus, let's go ahead and say 6, and then that should give us a 9. 5. Is that right? 2, oh, that was 1. Then that gets us a 9. That's right. Okay. So you can see how we can kind of construct now whatever numeric expression that we want to do. So that's good. Let's go ahead and make a commit here. And I probably should make a branch for the video. All right, so we said partial implementation. So let's just hijack that commit message. And we'll say complete. There we go. Okay. So a couple of things that I wanted to do now that we have that fixed. Is we're doing this get token a lot, and we have to keep saying the text and the length. So, you know, it's kind of becoming a common thing that we have to do. Sometimes we pass it and token's a pointer, or we have a pointer to a token. Right here we pass it and we don't have a pointer, it's the actual member, and again here and here and here and here. So let's go ahead and set up some helpful functions for us that will make it so we can just say, hey, here's the current one, just get me the next one. So I want it to be, it's going to return a token, and I just want to say and we want one when we have right. Oh, I forgot that we can't have the same name for stuff. So what do we want to do? Let's do we'll just do this, the one that has a pointer for right now. And we'll say next. All right. I'll get next token. I don't know, helper function, I suppose. All right, so the other thing that we had been talking about was we don't have a way to know where we currently are in the in the file. So this 2 right here represents the 2 bytes that we have to output for the boot sector, boot record signature. And the 2 bytes here represent how many instructions we have before this, but we don't necessarily know what that is. So we would have to continue to change this if we had more instructions. So what we're going to do is we're going to introduce two special tokens, and it's going to be dollar and double dollar. So this is, I don't know if this is widely used in other assemblers, but I know it's used in the one that I'm kind of basing our assembler off of. And what those are going to mean is dollar means the index or the value of our current line starts on, and double dollar means the value that the current section starts on. So for us, for right now, the section is going to always be 0, but we're still going to add the tokens and make it work. And then the dollar is going to be what knows how far along in our boot sector we are so that we can get the math correct. So ultimately, it's going to look like this. So you can see why we needed to do out these expressions and everything and add the parentheses. So let's go ahead and add this. So we'll say beginning of section, beginning of line. Okay. We can add that here. I don't know, I guess we'll keep the same thing that we're doing. When it's 1, we'll do it the one way, and we'll have to fix that at some point. Come up with a common way of handling all that. Okay, so now we're processing those, but we're not doing anything with them in our actual assembly piece. So I'm going to go ahead and we'll say just go ahead and set it. And I'm not entirely sure what denotes a section. We're not at the point where we have different sections right now. And so what we'll do is we'll just have this variable. We'll hard set it to 1, and we can update it when we get into where we're handling different sections. And then we'll just update that variable so that whoever wants to use that has access to it. The thing actually, though, now that I think this through, is that we actually need that in our expression processing, which is going to be outside the scope of this assemble. So it seems like we're going to have to introduce them and have them be global variables. And I did not introduce that, so we'll fix that. So we'll just say here we have beginning of section. We do need it for the line. And I think that's in our types. Nope. We have a macro? We do. Okay. So we're just going to introduce a new macro for static so that when we'll be able to identify what these guys actually are. Okay, so now that we have that set up, down in our assemble method, we need to set what the line is when we go to a new line. So what we'll do is we're going to have to introduce handling the end of line. And when it's the end of line, let's think about this. We're going to say, oh, it's currently the end of line. We're not going to output anything, and then we're going to go to the next token. So I think all that we have to do is then just say the beginning of line is the current index. And when we get to where we process sections, we'll have to do something like this to be able to capture where that occurs in our output. And then here in factor, what we need to do is we need to say if you're looking for the beginning of section, do something. If you're looking for the beginning of line, do the other thing. We don't need to consume the current token. We do want to move to the next token after we handle it. And then what we'll do is we'll say the result. I think we just set result equal to the value of those global variables. Okay, so we already updated our input. So that did not work, which I'm not entirely sure if I'm surprised or not. Okay. I think maybe something. All right, so that's the. So we're going to be processing the new line. Although the type's coming back as 0, which is wrong. And that could be because I might have forgotten to. No, we had that. Oh, you know why? Because I messed up. There we go. So when I copied out the end of line, I somehow must have deleted it when I shouldn't have. I want it there for right now. Okay, so we get some results, but we don't get, we lost our boot record signature. That could be because we're calculating too much. So I'm just gonna trim this in half. We can't do a divide, so I'll just manually do it. Okay, so you can see here's our boot record signature, and so we're slightly off. So it's not this dollar minus dollar dollar is not doing it correctly. It's not getting evaluated correctly. Let's figure out why. All right, so we're on loop piece. This is a end of line. Let's make sure this. That's correct. So that's the jump instruction. This is the end of line. Index should be 2. End of line should now be 2. This is going to be the times. Sorry, we're going to process another end of line because we have a blank line in the middle, in between. This is the times. This is going to then process our calculation here. So this first one's going to be get the 512, and we're at a minus. This is going to get us the 256, so now our result should be 256. We're at a minus still, so that's going to drop it down an additional 2, the minus, and then it's going to go okay, it took a jump that I wasn't expecting, but that's okay. The beginning of line's 2, so that's good. It's not an asterisk. It is a minus. Oh, man. It needs to be that. Okay, so now you can see that the boot record signature is lining up correctly. So I need to take the additional piece out. You can see now, so now we're back to our working boot sector. But the nice thing now is that I can come in here and add a whole bunch of other instructions and other inputs that I want to put into our boot sector. And well, that kind of came out to a bad value, but you can see here we have ODs here, but our boot record signature hasn't moved because of this dollar minus dollar dollar. That's keeping it at the spot that we want. Okay, so I think that's going to be good for tonight. Let's make a commit for our new changes. Okay, so just a couple of questions. They're all from Sinocron. He asks, why make an assembler for an OS? And the reason why is because I decided to go ahead and build the tooling that we need for it as well. So that way it's going to be, that way we're responsible for everything that is then running on the CPU. There are tools out there that you could use, but I wanted to do a little bit of work and build out these tools to just help just to help get a better idea of what's involved and the what's needed to do it. And that's really it. It's just because of that. He also asked, what's DB? And that is a token in the assembler that says that means define byte. And what that will do is you typically, like right here, we have a couple DBs, and that's just basically tells the assembler, I want you to output this value at the current output location in the file that you're producing. So it's basically just like, write this byte at the current location that, as you're building out this binary file, write this byte at that spot. He also asks, why name it times over multiply? The reason for that was because no particular reason. When I was looking up these values, I decided to go with the name that the ASCII name for these characters. That's it, and we can change them at any time. They're just what we chose to call them in the system. There's no reason than that, and again, they could be whatever we want. He also asks, what instruction set do you output? And so we're writing the binary output for x86 processors. That's basically going to be the main CPU that we're targeting for right now. If we choose to target different ones, we of course would have to add the infrastructure to be able to swap out what the instructions are. We don't have a lot of hard-coded instructions. The only one that we actually have is the one for jump right here. And it's just hard-coded, so you could see where if we wanted to support different CPU architectures, we'd have to have a way where we could look up, oh, okay, what's a jump instruction on the CPU that we're targeting. And we might do that down the road, but for right now, we're just trying to make life simple. We're not trying to build an all-purpose assembler. We're trying to just build an assembler that works for just our needs, so it doesn't have to be vastly robust. It can be stripped down and just do the exact thing that we need it to do. It looks like that's all the questions that we have. So I hope you enjoyed this video. Next time, I think what we'll do is we'll continue on with adding more instructions now. Now that we've made our life easier with not having to constantly update this times to get the boot sector size correct, we can add instructions up here and not have to worry about that and know that we'll be able to still boot into our boot sector. So we'll look at doing some work and adding some instructions to be able to get our CPU to be able to get our OS to do some trivial things, but they're the right steps in the right direction. So until then, have a good day.